Hello, and thanks for listening to us. I will present you today a new product of DWA, e-learning trainings on construction maintenance and rehabilitation of sewers and drains. Very specific topic, and I will give you a brief few insight that trainings together with the developing partner of DWA, Mr. Robert Stein, showing you some elements out of these trainings and finally having a short discussion round. E-learnings with DWA, that means 6 trainings, each of them for about 30 hours of working in a self-directed way. That means you can work the 30 hours whenever and wherever you want. And finally, a test which gives you a DWA certificate of your learning success. Here you find the overview of the trainings. The first one directed as introduction to wastewater collection systems. Then we have elements talking about different installation methods, open cut method and tunneling trenchless line constructions. And finally, the question of maintenance, cleaning and replacement of sewers and drains, which will be the contents of these trainings. 6 trainings, each of them 30 hours, 120 hours of learning. More details on the website you find here on the slide in the bottom. What is common of all these 6 trainings? Common is that they all have clear learning objectives and a good structure to find the content again you want to enter into the training. So 200 to 500 pages of courses. This is well adapted for 30 hours self-learning activities. And a very important element that they are illustrated very well with drawings and photos from the practice. The developer has his own consulting and construction company, so a lot of pictures really come from the practice, from his practice. Diagrams, tables and schemes according to science and according to the technical valid standards. At the end of a lot of lessons, you find exercises and learning control units. So the 6 courses for self-studying with a written test and DWA certificate, they are directed for refreshers in sewer construction, for all who want to enter into that field deeply, as you can imagine, as planners, as approval authorities, and as students. Feel free to register over the website of DWA. And now I want to hand over to Mr. Stein, who will show us much more than this demo views you see on this slide here. We have the opportunity to look into the program. Thank you, Mr. Stein.
Thank you, Mr. Knitschke, for the kind introduction. Welcome, ladies and gentlemen. Yeah, it's a pleasure for me to introduce Unitrix, the e-learning platform. Yeah, Unitrix, this acronym stands for Underground Infrastructure Training and Competence Center. And I'm already on my personal desktop. You see on the left my Unitrix. And this desktop welcomes me. And here on this desktop, I have all my e-learning courses, and I see also the progress of my studying. So I would like to give you a short introduction how it looks like with this course Utility Tunneling. If there's a possibility to start a course new or to continue, I do the latter one. And so we are here in the so-called platform mode, which gives me now the possibility to maneuver through such a course. But I would like to switch to the presentation mode, which is more or less something like from PowerPoint presentation. This course has below here some icons. One is, for example, to extend here navigation through the course. It has also here the left and right arrows to maneuver through the course program, a search window, and here's additional information. So let's jump to some specific pages, which enables me to give you a better impression how it works. Mr. Knitschke already mentioned that we work with a lot of graphics. And an important part is, in fact, visualization. Here, for example, we are now in the topic microtunneling. First, the definition, how it works. And you see on the left, two graphics, a man outside the pipe and a curved street. So on one glance, we see when we talk about microtunneling, we talk about pipes without man entries. They are small diameters, and microtunneling means we can steer the machine, we can drive curves. So with this picture language, we try to motivate you or to initiate intuitive learning. And here, for example, we're in a specific section of microtunneling, for example, now with soil displacement, which is shown by the last icon. Let's go to pipe jacking. So I jump to page 162. And here we see now the difference. Pipe jacking means man entry pipes, so pipes with a diameter which enables an access, and this is with one glance can be seen. I will go now through some of these pages. How the concept is here again, the general outline of such a construction site. You can highlight the picture and see then the agenda. Below, for example, you find a video. I cancel the sound. Here, this gives us an overview how fast such a machine is, and you see it's not that fast that it's worthwhile now to watch it quite long. It should just give an impression about the reality. Yeah, then you maneuver through the different steps. Here, for example, main jacking stations, and again, this gives you an impression how the content looks like. And here, for example, the different outlines of the main jacking station with the different cylinders. Also, again, using these 3D graphics, or then real graphics from the job sites. And if you want to learn, for example, more about steering, then you can, for example, also use this search window. And let's go, for example, to steering of the jacking works by means of steering cylinders. So we are here now on this page with an interactive animation showing the working principle of steering cylinders. And you see here 4 pairs of cylinders. In the neutral position, they are on 0. And then there's a minus position and the plus position. And you see also this arrow and as a horizon. And you see how they have to extend, for example, or to be neutral, or be drawn in to enable now these different positions of steering. This is an example how you by yourself can do some research and get a feeling about the theoretical principle. Let's go to the next part. Here, for example, intermediate jacking station, same principle, 3D visualization of the general principle of such a system. Here, the description also mentioned that problems may occur. Here, for example, an under-dimensioned steel pressure distribution ring of an intermediate jacking station. And now you can go through this content. You see pictures of such systems with integrated cylinders and not integrated cylinders. The different components here are described. The principle of operation when using intermediate jacking station here in the picture. And for example, again, for a interactive graphic, which enables you to get a better understanding on this process. This animation, for example, shows the development of the main jacking force here, provided from the main jacking station in blue. And at a certain point onwards, the intermediate jacking station here shown in green is activated. And due to that activation, the maximum jacking force from the main jacking station is somehow stopped. There's a maximum value which will not be crossed because the other jacking force needed is now provided by the intermediate jacking stations. And here, for example, now even the second comes into place, shown in red. So with that, I can now start to get the feeling of the process and, for example, the load distribution due to these systems. Let's go a bit more practical. We go to the topic diaphragm walls. Here again on the left side, the explanation. The general principle explained by 3D graphics. Also here, for example, there's a video showing such an excavator in a diaphragm wall operation mode. And for example, then the entire process is described how to build such a diaphragm wall installation up to the part where I install the jacking machine as explained here. And now you can go through these pictures and get an real close insights about such a process. Here, for example, the construction of the buffer wall, the completed buffer wall, starting of the excavation, the reinforcement cages for the diaphragm wall, the concreting of the diaphragm wall, the shipping of the top of the buffer wall and diaphragm wall. Then the installation of the top cap here with the reinforcement, the concreting of the top cap. Now I just go very fast through to give you an impression of the details shown and explained here. So the idea is to distribute theory and practical knowledge. And as you have seen, this is done by a lot of visualization, which is the main part of this concept. Let's show another part. For example, sinking shaft. So, sorry, I have to do this here. Here again, open sinking shaft sinking method. It's explained by a series of 3D pictures, how it is done. You also have a full animation showing this process. I will not show it here, it takes too long. Up to the visualization of extreme new technologies like vertical shaft sinking machines, for example. Advantages and the disadvantages are explained. And shaft boring methods, or another part for details shown here. for example, gasket opening seals. Also here, the different systems are with high quality graphics visualized, and we also then included, where possible, pictures from job site construction. So all together, we enable with that a deep understanding. So just an introduction to trenchless installation, showing utility tunneling methods. Let's go back to another alternative. Let's go into the field of open trench installation. Also here, I would like to show you a course, which is also provided by DWA. Let's find it. So here, I just come to a page with traffic control. This is an interactive exercise which enables us to get a better understanding how we have to secure the job site to enable public trafficking. Here the risks are explained because of the excavator. There's a danger zone, and we also need the space for construction traffic, for public traffic. And here now we see how the job site is secured. So to prevent this effect, that there will be an accident between a car and the excavator, the traffic light sequence is installed. And here we see now the process, how this sequence of traffic, where traffic is allowed and safe operation is possible, is integrated. Yeah, I stop here. Let's go to some other pages. Here, for example, what are the requirements for a trench base? Again, here we use the same concept of a high quality visualization to explain the setup of the bedding area, and we can now go through it. We use these 3D graphics and the real pictures to enable a better explanation. And this is especially important when we try to communicate technical details which are very special. For example, here we see bedding types which are mandatory in Europe based on the European standard 1610. And this is a more or less standard graphic, just colorized, where we see the layout of the different bedding layers. And on the left, we see the same picture, but through this 3D graphic, you can, for example, now see how the pipe is in fact installed. And we see here that the pipe coupling is based in the first bedding zone, which normally could not be seen directly by the two-dimensional graphics. So this is a simple understanding of how the effects or the benefits of 3D visualization work. And the concept, just one last page here, for example, flowable fill. Here the same concept is applied. We use this 3D graphics and the real job site graphics to enable a better understanding. And this goes throughout the entire course. And with that, I say for the first time, we generated a learning quality and a learning depth, which is worldwide unique. And from my point of view, I don't know other fields where this amount of visualization took place. Yeah, ladies and gentlemen, with that, I would like to stop the presentation of the learning content. Thank you very much for your interest.
Mr. Stein, thank you very much for this practical demonstration. We have seen this training content really is directed to expert know-how. It's very well visualized, and this is a lot of work, I can imagine. I'm asking myself a little bit how there is a challenge behind. How can such a material, which is developed with so much energy, how can this type of material be maintained so that it's following this technical progress?
Yeah, thank you for this question. On the first side, we have an advantage, a big advantage, because our business, pipe installation, pipeline management and rehabilitation, is not like manufacturing of computer processors where you have an extreme innovation every year. So we work with installations which are in place since 100 and more years, for example. So it's not that fast. Nevertheless, there is a progress. So on the one hand, what we do is to collect knowledge of all historical installation processes and rehabilitation processes and continue to describe the current technical situation. This, in fact, is a certain effort, but it's not, luckily, not that much compared to the collection of the developed techniques in place. So the workload is handleable. Nevertheless, one important part is the correction or the editing of what we develop. And here we benefit from our cooperation that USDWA have experts who revise the content and who take care that the requirements you just mentioned, that they are technically correct and that they are up to date is with that guaranteed. And so we benefit from this joint venture in that regard.
So until now, we learned a lot about the content of these e-learnings. We learned about the development and the challenges of the quality and visualization. But Mr. Stein, we didn't talk about the participants. We didn't talk about the learner who has to spend 30 hours in 30 days of learning by himself. This requires a lot of self-discipline and a lot of self-motivation. Obviously, at the end of the training, there is an exam, a DWA test, written exam, which can be organized even in your daily time schedule. And based on that, you will get a DWA certificate of this training here. But to come to that point and to make sure that you're on the right track, are there any instruments of self-control in our training courses?
Yes, there are. But for me, I would like to start with the first point you said or mentioned, self-motivation, because this is the essential part when we talk about e-learning. E-learning, from my point of view, only works with a high degree of self-motivation. So the question is how we achieve this. And there I would like to give you a brief example. Again, here you see part of a course. It's a pipe bursting. And this slide shows the 3 aspects which influence the bursting force. And we can read it now. It's a breaking resistance, the displacement capability of the soil, and the amount of expansion.
So this is a learning unit.
Yes. And normally, if you just would read the 3 bullet points, okay, yes, you understand it. But I promise you will forget it very soon. And with these pictures now, you get an intuitive understanding and you memorize it quite different. It's extreme how good memorizing happens with these pictures. And what I said at the beginning, intuitive learning. Intuitive learning, what does it mean? It means easy learning, easy understanding. And this generates a motivation. And the other aspect for the motivation was with the quality of the graphics, to provide a certain kind of entertainment. And these two components, the quality of the graphics itself, but also the way how we visualize content, enables this kind of required motivation and makes, from my point of view, Unitrick unique. The second part of your question, yes, I guess it's very important that the learner gets a feedback. So at each end of a lesson, you have a kind of self-test, a questionnaire, where we pose certain questions about the content learned, and you have then to find the right answers. You can get hints if needed. And so if you pass on this self-test, for example, you are more or less able or recommended to continue with the next lesson. So with this self-test, we enable a certain kind of feedback to the learners, so at the end that he is self-confident to go to the written exam.
So this was an introduction about the e-trainings, e-courses, about Azure rehabilitation, construction and maintenance offered by DWA in cooperation on the platform Unitrack. And I'm very thankful that you, Mr. Stein, had been here. We both hope this presentation was helpful for you. If you have any further question, please contact us. And some last words from you, Mr. Stein?
Yeah, thank you for taking the time to watch this video. And we say always, when you finish a course, stay curious. And yeah, maybe we see us again here on Unitrack. Thank you so much.
Hope to see you soon in the training.